Hello Go friends, and welcome back to part 7 of Introduction to Go. In this video, we'll be learning about strings that will be consisting of the only UTF-8 characters, rune which will consist of UTF-32 characters, and how to declare constant. In constant, we'll also understand how to declare some uh, enumerated constants like enums in other languages. Before we start, please do not forget to like, share and subscribe to our YouTube channel. Also press the bell icon so that you don't miss on any new notifications. Topics that I'll be covering today in this video are string, rune, constants, and in constants we'll also understand an important concept that is iota, which is helpful when you are about to create some enumerated constants like enums in other languages. So now let's start by understanding the basic data type of type text, that is string. The string type can only hold characters that are there in UTF-8 character set. So here I have declared a variable by the variable name as name, which contains the value as Jon Snow. I'll print this value and let's see if it is printing. Oh, it is printing. Now let's also create another variable area as string and say India. Now, when I try to concat, when I add these two area, so the addition operator, there is only one operator that is allowed for strings, that is an addition arithmetic operation. This arithmetic operation does concatenation of the two strings that are to the right and left of the plus sign. So now if we run this program and see, it has concatenated both the variable and printed at once. Now, if we want to see the type of the resulting variable, so we can even do that percentage s and percentage capital T for type. Now, this is the resulting, so this will be replaced by percentage s, and this will help in replacing percentage T. Now, let's see and run this. So it is giving me that this is the output percentage s and then this is type string. Then because the resulting will again result in a string type. Now we also have sometime a case where we want to replace certain characters in string, or we want to access a particular index in a string. So that is also possible because string type is nothing but a collection of characters. So if I want to access empty dot printf, let's say percentage s, and I want to print only the first character of name. So as index starts with 0, so I can directly go ahead and give index 0. So this will be printing the first character of the variable name. Now if I see percentage f is okay, now let's run this. Okay, because percentage s will be expecting a string literal, but this actually is a uint because a string is a collection of bytes. That is why it will not replace this easily. Now let's do this and then try to. So as a result, you can see I have got 74, which is an ASCII value for capital J. Now to get the exact string value, I'll convert this to string and then print this. So I've got J. So because we don't have a backslash n over here, it is getting mixed. We'll separate this out and we can see I've got J. Now if I give let's say 4, 4 means fifth element. So 1, 2, 3, 4 and 5, fifth character will be a space. So to be very sure that if I am getting it correct, I will put an hyphen on both sides of the percentage v, so that if space is there, we are very clear. So yes, it has resulted in a space. So similarly, at times when you uh, use a strings package, normally what they do is they convert this complete string to a byte array. So how you can convert a string into a byte array? Let's say I have a variable, say arr, which is of type, say, byte, and will have name passed to it. Now I'll try to print this and add a backslash n over here so that you don't mix these two, and percentage v. I'll remove this and arr. Now let's run this and see. Now if you see, this is an array which contains a list of ASCII characters. ASCII character corresponding to each character in the string that is contained in the variable name. So this is at times useful when you are doing some string operations or doing some string manipulation. So if you go ahead and you look at the strings package or any package that is actually dealing with some sort of string conversion or string manipulation, they are actually converting the complete string to bytes and then doing the manipulation. Because if I want this to be converted and I want to replace some character in, say, name string, and I want to replace only the first character, and if I give 97, so 97 is a representation of an ASCII value of A. So this is not allowed. This, if I try to run this, it will give me an error where it says that assignment to a particular index is not allowed in Go. So if you want to do that, you have to do by ARR, replace the zeroth character by 97, and then print this. So we have the older output which had 74 in the first character, and now if I see the result, it will have 97. Now if I want to see if by converting this to string, let's see if I can convert this to a string. Now if when it is converted to a string, I can see the capital J is replaced by the corresponding ASCII character of 97, that is a small a. So this is how you can manipulate a string or do string manipulation or things like that. So that's all on the string. Now let's move to rune, which is helping you to store UTF-32 encoded strings as well. So when working with rune, we need to understand one special aspect about UTF-32 characters. So any UTF-8 character is also a valid UTF-32 character. So in Go, it's very tricky to play around with UTF-32 characters. So we'll not go deep into that concept, and we'll just touch and understand how we can declare runes and what are runes, so that you can directly go on Go tutorial packages pages and you can directly refer to rune in case you want to deep dive into UTF-8 character handling. So when we declare a rune, let's say I have a variable, say test, and I want to declare it as a rune. So I will declare it with an single quote. So as against an example of string, if we compare, string has to be in a double quote, but runes have to be in single quote. Now let's see and print the type and the value of this. So percentage t, and let's say test. Now let's say, and I'll give line feeds over here so that the results don't get mixed. Uh, okay, I missed a variable again. Test, sorry. So if I see the type that is displayed for the rune data type is int32. This is because a rune is also an alias of int32. So you might be a bit confused that I have declared it using a implicit conversion, but we can again do it with explicit conversion as well. Rune, I'll assign a value of z, and let's print this t t. So now let's run this, and let's again. Please pardon me with that. I always intend to miss the line feeds. So if I see the UTF or the ASCII value of Z is 122, and the type that is there for test1 variable is int32 again. So runes are nothing but an alias to integer types, integer 32. Now, if you want to go deep into runes, let's see where let's see with an package. Go packages. We'll go into packages and go into strings packages, and here we can go and see how we can use runes. So runes like we have special functions like write rune, or we have other scan rune reader. So those functions are there definitely, like uh, this one read rune. So we have different functions which are helping you to read rune, write rune to a file or any type of writer, or replacing or playing around with runes. So if you are willing to go deep into handling of UTF-32 characters, you can go ahead and read this tutorial. I'll just put this link in the description of the video. Now let's move on and understand how we can declare constants and how we can use constants, how we can assign values to constant automatically or enumeratively, so that you don't have to explicitly at times give values to your enum sort of constants. So now let's start understanding how we can declare constants and how we can declare a enumeration of constants. So let's first start by declaring a simple constant variable of type int. So any constant that we have to declare will start with a const keyword. Const, then the constant name. In other languages that you might be using a constant, like in Java, C Sharp, or other languages, you might be using constant names as, for example, my stat static int values. These are normal naming convention in other programming languages, but in Go, if you declare such variable, such constant with a capitalized first character, then this is supposed to be exported variable. In case if you declare it in a package level variable, so this will be exported to other packages also. So in Go, we normally declare a constant as same naming convention to be followed as used in variable. So where I can use my static int value, and I can directly go ahead and assign a value 5. So as when you compare this declaration with an integer, you have to use like my int, you have to use a colon equals to operation to assign, but this is not the case with constants keyword. Now, if I try to print this fmt dot println, and I'll print sorry, percentage s and percentage capital T to get the type of this. My I use println, sorry, printf. my static int, and again I have to give my static int to print this percentage f as given two variables. Okay, now let's go ahead and try to print this. I think there is something that it wants to tell me. It is saying, okay, percentage s is used for string. I'll give percentage v a generic value type. So it says the type of static int that is automatically assigned is integer. That is same as in the case of declaring a variable. The auto assignment of any type would be either int or float 64 or float 32. That is same in this. So if you want it to be of particular type, you can give the type of the constant, and then it will give you the exact type that you want it to be. Now, at times you want to declare some constants uh, which can have some other values or some values that it inherits from other constants. For example, I have a constant, say x, which had a value of 6. Now I want this my static int to be plus 2 of the value of x. That is also possible because should know compiler should definitely know at compile time what is the value of constant. It should not be generated at runtime. So that is why, because now x is something that is also known at the compilation time, so this is definitely allowed. But if I use a math function and I want to assign math dot say sign, I give 1.5. So this is not possible because this function will be executed at runtime. So at runtime, value cannot be assigned to a constant. It should be known at the compilation time. So this thing is not possible in a constant. So we can definitely go ahead and give a value 5. Now, second thing that we can do is again shadowing that is there possible in a normal variable. So I can have a variable, a constant with value, let's say 60 here declared in the package scope, and then again I can declare this in the function scope. And if I try to print this, let's say I print x, and x, I mention over here x to be very clear so that we know what exact value we are getting. And now let's print this and let's see what value of x we get in the function. So you in the function, the value of x that is accessible is 6, which is in the scope. Now if I use this print statement just above the declaration of this constant, I will get 60 as a value, because in this scope the x was not actually declared, so it will take the package level scope. So first it is 60 printed and then it is 6, because at this moment a variable again with the same name is declared in the same scope. But if you try to declare it again in the same scope, it will not allow you to do it. It will say error, which it will say x is redeclared in the same block. So this is not allowed. And if I try to assign a value to it again, it will also not be allowed. It will say the constant value cannot be changed, cannot assign a value to x. So this is all about basics in constant. Now, at times you might be facing an issue where in other languages you might be using some enumeration or some uh, auto incrementing, uh, say constants. Say I have, for example, I have uh, let's say apple fruits, a list of fruits, and I want to give them. So you already know that if I want to declare more than one constant in one time, I can directly go and keep them in the parentheses. So I can declare a double apple. I can give a value as 1, then I can give an mango and give a value as 2, then again I can give orange as value 3. Now if you have observed, all the values that are there over here are all incrementing to one value. So if I try and let's say I can print this value of apple over here, and then this. Let's see what value do we get. Now for the value of apple is 1. Now if again, so this is something that is an incrementation of the same constant values, and at times you might be feeling that this is a reluctant type of code that I have to manually go ahead and do it. But in other languages like C sharp, where you can directly go syntax like enum fruits and then again apple equal to 1, you just assign it a initial value and then mango, then it automatically follows. So the same is also possible in Go, where you can remove this assignment, and if you go ahead and print the value of apple, then print the value of mango, I think it's like this, and now I can go ahead and print. Now you might be thinking that it should give me an error saying that uh, mango's value is not assigned, but if I see, I didn't save I think the file, and so if you see, the mango's value is also assigned to a value that is 1. So in Go, in same block, if you don't assign a value to other variables, it will assign the same pattern of value that was assigned to the first variable. Now if I say I assign it as, let's say I assign it as x plus 1, and x is actually a 1 value, or let's say 0. So it will follow the same pattern for mango and orange, and it will assign the same value to the same. So if I say, let's say I go with an increment operator, and sorry, x is equal to, sorry, x plus 1 I'll give. So this is also possible. Again, the mango and orange value will be, again, same values will be there. But in Go, we have a special keyword called iota. Iota is something which will automatically increment itself, and it is a substitute of this symbol when you want to use and start it with a 0 index. So I can go ahead iota. So if I give this value as iota, again iota to other also, and let's see what happens. Iota. Now let's run this program and see what happens and what value do we get of mango. Now if I see, apple has got a 0 value, mango has got an 1 value. Now it automatically follows the same value that you have assigned to first. So this concept, using this concept, I can remove these two assignment and directly go ahead and run this program. And again, if you see, mango's value is 1 because iota will always increment its value in the same block of declaration. Now, if I go ahead and constant name, sorry, constant block again I have where I say I have uh, roles like admin equal to iota. Then again I have uh, user. Okay, then I have staff. Now, if I go ahead and print the value of user and staff, admin, and then I'll print the value of staff. If I print these and check, see, again, if you see, the admin value has again initiated from 0. So iota's value will automatically increment in only one block of declaration and again restart from 0 in another block. So you can always go ahead and logically arrange your constants in same blocks, and you can do. Now, at times you might also feel that I don't want to start the value with 0. So to do that, you can have two ways where you can give an dummy variable like ERR and assign it to a value iota and never use it. So this will allow the error will get a value of 0 and Apple will get 1. So actual variables will get values with starting with 1. But in this case, you are actually exploiting the memory and using one memory block which you will never use. So Go has a special character that is called underscore, which is only which is called a write only character, where this does not occupy the space, but this is only for us to assign a value at one time. So if I run this, I will get apple as 1 and mango as 2. And again, in admin, as I have not given any of this the syntax, so admin was 0. So now I can go ahead and do this, and I can see that admin again starts with 1 and staff is again 3. So that's all for the constants. Thank you for watching the video. Please do not forget to like, share and subscribe to our YouTube channel. Also press the bell icon so that you don't miss on any new notifications. Also do comment us below on any feedbacks or any new tutorials that you want us to do.